Next page, the antenna advanced info. The advanced info page will be used during the commissioning and setup of your system. During this presentation, I will tell you the functions, explain a little bit about them, and in the next presentations where we do the actual setup of the antenna, I will show you exactly how to use them. Starting in the left top, the tilt sensor bias. On the system there is a sensor box, and inside that sensor box there are two tilt sensors, one for elevation, one for the cross level. And on top of the sensor box there is a water bubble, and during the tilt sensor calibration or the tilt sensor bias calibration, the aim is to get the level bubble, the water bubble, in the center. It's a simple procedure and I will show you later on how to do it. Next, the rate sensors. Inside the same sensor box there is three rate sensors. Three rate sensors, one for azimuth, one for elevation, one for cross level. And during a normal operation, the sensors will detect the motion of the vessel and basically drive the control loops in the opposite direction. So the ship moves in one direction and the rate sensor will tell the motor to drive in the opposite direction with the same speed as the ship moves in the directions. Next, the conical range. Conical range, during a normal situation, the system is tracking and the dish would make a small circular pattern, and during these circular patterns it's measuring signal in 4 quadrants. And by keeping the 4 quadrants equal, the system would point at the exact location of the satellite. The elevation adjust is basically a setting which is done from the factory, and with a properly calibrated tilt sensor, one should not change the elevation adjust. Search parameters. In a VSAT system we've got two search parameters, the type 1 and the type 3. The type 1 is used when there is no gyro connected to the system. The moment the system would go into a search, it would start an azimuth sweep, which is 400 degrees, and it would have an elevation range of 8 degrees. When there is a gyro connected, the search type 3 is active, so the system will calculate based on position and heading where the satellite should be, and it will point to that position. If the satellite is not found directly, it will start a spiral search, which is 3 degrees in azimuth, 4 degrees in elevation, and within that box the satellite should be found. Then the waiting time. The waiting time, if you use a DVB tracking, it will basically, after starting tracking, it will wait 5 seconds to receive a DVB lock. In situation where you use NBD tracking, it will wait 5 seconds after tracking to receive the modem lock or confirmation from the modem which is connected. The search step is in this situation half a degree, and that's the search step which will be used during the search type 3. Threshold settings. By default they read 40 and 20 for DVB and 40 and 20 for NBD. And during a initialization of the system, the received noise on the receivers will be put to 0. And if the system detects a satellite signal or a signal which rises more than 40 counts above this 0, it would stop. And if you get a 20 more, it would start tracking, and that's the same for NBD and DVB. TX enable. The TX enable setting is, it works in correlation with the conical scan. If during a conical scan a blockage would appear, then in one of the 4 quadrants the signal would drop drastically. And if this signal drop is more than 50 counts, which is the TX enable by default, the system would stop with the transmission. Then the block zones. In the system you can program 5 block zones, starting from the bow clockwise to the bow, and it's a relative. So the relative angle from the bow should be filled in. The first is the azimuth start, the second one is azimuth stop, and by doing that you can do 5 different block zones. On the right side you'll see a graphical presentation of the antenna, where it's pointing relative to the north and where it's pointing relative to the heading of the vessel. Same goes for elevation. It will show you the elevation angle under which the system is currently tracking.